We have learned about one-dimensional array. Now it is time to understand two-dimensional array. Two-dimensional array is actually a tabular structure where we have row-column orientations. In C, we declare a two-dimensional array in this way. We need to mention the data type that comes first, then the name for the array, and then the number of rows and number of columns in two square brackets. Now this declaration particularly indicates that X is a two-dimensional array with 4 rows and 3 columns where each element is of type integer. Now we can think this structure as a tabular structure, as I have already mentioned, but practically it's not tabular in the primary memory. Rows are allocated one after another contiguously in the primary memory. I will discuss about that later on. So while doing the programs, we considered this as a tabular structure that helps us to think in a better way. So we can think this array as a tabular structure with 4 rows and 3 columns. You can see that there are 4 rows and there are 3 columns. And the index for both rows and columns starts from 0. So the index of this row is 0. This is index number 1 for this row, and this is index number 2, this is index number 3. Column index also starts from 0, and this is column number 1 and this is column number 2. So for a two-dimensional array with m rows and n columns, we say typically m cross n array, the row index varies from 0 to m minus 1 for row index, and the column index also varies from 0 to n minus 1. Now, in order to access a specific cell of this tabular structure, we need to mention both the row index and column index along with the name for the array. So if I want to assign, say, 5 here in this cell, then the row index for this cell is 1 and the column index for this cell is 2. So the typical statement for assigning 5 to that particular cell will be x, first mention the row index, that is 1, and then mention the column index, that is 2, in 2 square brackets consecutively, and then we assign the value that we need to assign at this cell. So 5 is assigned here after this particular statement. Now if I want to access this cell, say I want to assign 10 here at this particular cell which is having row index 3 and column index 0, so in that case I just need to mention x3, first comes the row index, then the column index, and then we assign the value, say 10. So 10 will be assigned here after this particular statement. So if I want to access some ith row and jth column, then the typical syntax is this: x, I, and then j, where I is the row index and j is the column index. And then we can just mention some value here to assign the value here at particular cell. As I have already mentioned that although we can consider this as a tabular structure, but practically it's not tabular in the primary memory. If we are considering an array, then array is always contiguous in the primary memory. So the practical allocation of this array will be something like this. The rows are contiguously allocated one after another. So if this is the first row, row number 0, it is having 3 columns. I'm just using red color to demarcate amongst the columns, and then comes the second row. Second row starts immediately after the first row contiguously in the primary memory. So this is the second row, that means this is row index 1 and this is row index 0. So actually this is column index 0, this is column index 1, this is column index 0, this is column index 1, and this is column index 2. Again, for the second row, the column index is 0, 1, 2. So this is column index 0, this is column index 1, and this is column index 2. So if we are having 4 rows, then the 4 rows are contiguously allocated. Now this is row index 2 and this is row index 3. So this is how the practical allocation takes place. So if I assign, say, x 0, 2, that is row index 0, column index 2, so that means it is actually referring to this particular cell here. So if I assign 10 here, to 10 will be assigned here. If I want to access this particular cell, then it is row index 2 and column index 1. So I need to mention row index 2 and column index 1. Say I am assigning 5. So 5 will be assigned here. So please remember that whenever it is an array, we are talking about array, then it is always contiguous in the primary memory. Although we can consider two-dimensional array as tabular structure and can visualize it as tabular structure while writing our programs, but practically it's always contiguous. And this conception is going to help us to understand the relationship between two-dimensional and array and pointers later on. We can iterate through the cells of two-dimensional arrays using nested for loops very easily. Here we have declared a two-dimensional array with 4 rows and 3 columns. I'm going to assign each cell of this two-dimensional array using a nested for loop. So we are declaring row index and column index as I and j. These are going to be utilized as row index and column index. And I am first of all iterating over the rows, and then for each row I am iterating through the columns. Now if I mention xij here, say I'm just assigning I multiplied with j, then what's going to happen here? Let me just make you understand this clearly using try-run method. So here is the array that is having 4 rows and 3 columns. This is the array that we have. Now when the for loop starts, the outer for loop that is actually having I as counter here, it starts from I equals to 0. Now here I is actually considered as the row index, so I will be acting as the row index. So I starts from here. We have I equals to 0. Now 0 less than 4, that is correct. So I will maximum vary up to 3. That means I will come up to here, up to 3, the last row. Now I is 0 currently, so 0 less than 4 is true. So it is coming inside of the outer for loop and it gets the inner for loop. So the inner for loop iterates from 0 to less than 3, that means up to 2. In the inner for loop we are using j to iterate over the columns. So j starts from 0 and 0 less than 3, so that means j will maximum come up to 2. So 0 less than 3 is correct, so you are entering to the inner for loop. Here you get this statement x 0 0, that's the value for I and j right now. I is 0, j is 0. So x00 means this particular cell, the first one. It will be assigned with 0 multiplied with 0, that means this is going to be assigned with 0. Now the inner loop is going to iterate once more. The value of j is going to be increased by 1. It will come here for I equals to 0. I will remain at 0 because we are iterating in the inner loop right now. As long as the inner loop is true, it will go on iterating within the inner loop. So j plus plus, that means j goes to the next column. J plus plus will take the value of j to the next column, that is 1. So j comes here. Now 1 less than 3, that is also correct. It will come here. Value of I is 0 and value of j is 1. So x 0 1, it is actually indicating this particular cell, the second one. 0 multiplied by 1 is 0, so it's going to be assigned 0 here. Now again j plus plus will take j to the next column, that is 2, so j comes here. Now 2 less than 3, that is again correct, so once more it comes inside the nested loop, and now the value for I is 0 and value for j is 2, so x is 0 2, that means this particular cell is going to be assigned by 0 multiplied with 2, that is 0. So all the elements of the first row is going to be initialized with 0. Now when j is incremented to 3, this particular condition is false and the control comes out of the inner loop. So the inner loop is done for once. Now it goes here and increments the value for I to the next row, that means 1. So I is incremented to 1. Now I comes here. Now again 1 less than 3 is correct, so the control enters into the inner loop. Again j starts from 0, as you can see that, and j will go up to 2, the maximum column index that we have. So again we start from here, j equals to 0. So now in this case x10, the value for I is now 1 and value for j is 0. So x10, that means this cell is going to be assigned with 1 multiplied with 0, that means 0 again. Now the value of j is going to be increased by 1, so j will come here, and now 1 multiplied with 1, that is 1. Now again j will be incremented to here, value of j will be 2, so this is going to be assigned with 1 multiplied with 2, that is 2. Now again I will increase to the next row, that is this one. J again come back to the first column, that is column number 0. So again it will start iterating for row number 2. So I is here at row number 2, again j is 0, so this is going to be multiplied with 2 multiplied with 0, that is 0, 2 into 1, that is 2, 2 into 2, that is 4. So for the I will be incremented to this particular cell. Now for this cell it is 0 again, for this cell it's 3 into 1, that is 3, for this cell it is 6. So this is going to be the content of the array after this for loop is executed. Now when value of I becomes 4, then 4 less than 4 is false, it comes out of the loop. So using a nested for loop, we can iterate across the two-dimensional array. Each cell could be accessed, and this is the most convenient way to access each cell. I'm just again writing another for loop to print the content of the array. I'm writing a prompt. After printing each row, we should print a new line so that the content of the next row is printed on the next line. Otherwise, all the rows are going to be printed on the same line. So I'm just printing a new line character here after printing a row. You can see that again I'm using the same nested for loop in order to access the cells of the array. When the value of I is 0, all the cells belonging to the first row will be printed by this j loop. J loop is going to iterate from column number 0 to column number 2 for row number 0, and then again the row number is going to be increased to 1, and again the j loop starts from 0 to 2. So if I just go on executing this program, then it's going to print the array, each cell of which is assigned with I multiplied by j. Here you go. Here you can see that it's exactly according to our discussion.